But take a look at these diagonals. These diagonal pieces right here, when I look at it from the top, they're not gonna be true size. What are they gonna be? Foreshortened, foreshortened. And when I look at them from the right side, they're foreshortened too. So all these are gonna be foreshortened. So if on an engineering drawing, we feel like it's really important to communicate what this plane actually looks like and what its true size is, we have to do something that is called an auxiliary view. So for instance, let's take one of these. Okay, here's this house, right? Or it looks like a house with a roof. And the roof, there are angles there. If I just look at it from the top, it's going to be foreshortened, but I really want to know what the true size of this is. What way do I have to look at this if I want to see the true size? Perpendicular. I have to look at it perpendicular to really see the true size. So in this particular case, looking at, let me show you what we do in auxiliary views. Look at this one. Here again, front view, top view, side view. We see that this is inclined. If this is inclined, when I look at it from the side and from the top, again, they're foreshortened. If I want to show the true size of that, I have to view, my line of sight has to be perpendicular to this point. And now I'm going to do something that's very similar to what I'm doing, but instead of converting it from the top view and the side view, I'm actually creating something that's referred to as an auxiliary view. Auxiliary view means extra. We already know that a standard part needs to be communicated by 3 multi-views and a 3D view. If the 3 multi-views are not complete, we already learned last week that we can do a sectional view, right? Or a couple weeks ago. The other thing is if a sectional view isn't going to help, you might want to have another view that actually shows you the true size of something. And the way you do that is you have to carry out these lines perpendicular to the surface and find out, doesn't it make sense that this is depth, this is depth, this is depth? Because if I'm looking at something from the side, whether I'm looking at it from the side, I see depth, the top, I see depth, and if I orient it like this, I see depth. It's all the same. So let's look at another slide, another example. So here's the front view of a part, and here's the right side view of a part. Can you picture what this thing looks like in 3D? So picture a piece of wood that looks like this, but when you look at the side view, what did you say? What's going on right here? There's a hole that's going through it. But on the right side, because this is diagonal, the hole looks like ellipses. It's weird. So you might want to show what it really looks like. So I'm seeing what the true size of that side is and the circle. Yeah.
Why is it like cut off right there?
Why is it cut off?
That's like the cutting thing?
Yeah, this is not a cutting plane line, but it's a short break line. Because it's just showing you that there's still the rest of the part, but the only thing I really needed to communicate right now is this. Because this part right here is communicated fully by just having the front and the right side. Okay, let's look at another one. All right, everyone look up here. When I look at this, and I look at this, does it look like this is a circle? You see a circle here, right? But what's happening? This is really sliced. It's a cylinder that's out here, but if it's sliced diagonal, that cut is really going to look like an ellipse. One more page. Here's another one. Here's an object that when you look at the top view and the right view, they really are not very helpful. But if you draw lines coming out, you could actually see what this part looks like on the side, and it's only showing you part of the auxiliary. So now, the fact that this is a diagonal, the surface is a diagonal, over here, this is actually sliced here, so this is foreshortened. And I wanna show the true size of that plane. And the way I find the true size of that plane is to actually come out from here perpendicular. And actually, you know what, I think what I'll do, I think I'll just put another piece of paper on it, on top of it. So I'm gonna come out, and I'm gonna draw lines that are perpendicular to the surface. And I'm gonna flip it. And I drew my fold line here, and now I'm gonna draw a fold line here. And this fold line is the front to the auxiliary view. I know that point 1 and 2 lie on here. I know point 3, 4, 7, and 8 lie on here, and I know points 5 and 6 lie on here. So then I'm gonna take my divider, and 1 and 3 are right there. So here's 1. This is where I know is point 1. And I know point 3 is right here. And then I know point 5 for my fold line. 5 is over here. Here's 5. And then point 6 is along here. Again, I'm measuring from my fold line. Here's 6. From the fold line over, 2. Here's 2, and the same as here, which is 2 and 4, and 4 is along here. This right here is the true size of that inclined surface. It's an auxiliary view. Roland, Roland.
It's okay. Did you just decide to put the fold line any
You can put the
distance?
fold line wherever you want.
Okay.
The way I decide where to put the fold line, I put it pretty close to the object, because I know I have limited space up here.
And it's,
So I put it close, because I'm measuring everything for the fold line, and then I'll put the fold line down here as much as I can.
okay.
And you have to label the fold line, it's the front to the auxiliary. But notice that I wound up using the dividers, right? Do you want me to, maybe I could post some YouTube videos of doing this as well? That sounds like a good idea. Okay, let me do that, because you're gonna wind up leaving here before you finish all these sheets, so it's probably a good idea.